Thankfully, we didn't record that. We're just going to go over one kind of thing today. One of the questions when I kind of did everything here, I have the answer to that one as 2.509 because 132, um, like I look at this as, well, 132 is 2 times 61, 60, no, 70, 66, maybe. I don't know. Let's do the smart thing. 132 divided by 2, 66 divided by 2 is 33. Well, that's 3 and 11. There's no 7 to any power in there, so that gets to be a problem. Um, I put this one in here. This is just a summary of our stuff. There's some extra practice in here that you can do if you choose. Um, this is, Mrs. Legier's converting to base 10 because there are some things, log base 7 of 22. 7 to what power is 22? Well, I don't have a calculator that does log base 7. Um, so the first thing we do is put it in exponential form. So 7 to the x equals 22. Then we log both sides because,
I can't see the screen.
what? Did I not share it? Ah, shit. Sorry. Oh, all right. No, that's my fault. This is what I was talking about. The 132 is 2 times 2 times 3 times 11. Um, I can't do the log base 7 of that. On this page here is the review of our rules. There's some extra practice which I'll fill in um, the answers later. So if I want to find the log base 7 of 22 or the log base 6 of 38 or any number where you can't kind of do it in your head, we want to write it as an exponential, and then we log both sides. You can do this as base 10. You can also, this is actually going to work. I don't know why I always write H. If you use ln as well, it's the same process. Well, if I have log base 7, log of 7 to the power of x, I can move the x down, use the power rule to put that in there. This is a product, so I can divide to get x. So log base 22 of log base 7 of 22 is log 22 divided by log 7 with base 10. You can, like I said, you can do it with ln because 22 over, if I do that in the calculator, I'm going to do 22 log divided by 7 log equals 1.58, 22 ln. Even though these numbers are fundamentally different, 7 ln equals, it works the same way. You're going to run into some people and some books, if you keep going, that use the natural log more commonly. So if x is log base a of b, x is the log of b over the log of a, or the ln of b over the ln of a. So once you get it to that point, you pull out your calculator because anything like up here, you should be able to do without a calculator. Even if it says evaluate, uh, if we were to have an exam I would probably design most of it so you don't use a calculator, just because. So I'm going to go back over to here and just go through this one. So we have, if this equals x, no, that's the wrong color. Go away. Let's use red. If that equals x. So 7 to the x equals 132. Log both sides. Move that down. Divide log of 132 divided by log of 7. And this is what I did. You, would I expect you to go through and show all of the steps? Not really. If you say log base 7 of 132 is x, and then went to here after a while, 132, because I wrote log divided by 7, log equals 2.509. And that's how we got that answer. So that's kind of the trick um, to doing that conversion. I'm gonna have to shoot. There's this whole disappearing act is great if you're not saving things, but if you're saving things, if I, okay, they're all up there, but they don't get in the way. Quarter, finger front. Shit. Okay, I guess I have to put it down there. So convert to base 10. So this is kind of it. X equals. So this is as simple. And then we throw it in a calculator. 152. No, don't. There's a keyboard shortcut to all of the functions on that calculator. I just don't know what the log one is. Divided by 4 log equals 3.624. So 4 to the power of 3 point should equal, give or take, 152. So 4 fours are 16, 4 16s are 64, 4 64s are a significantly larger number. So 4 to the power of 3.6, 4, 3.624, 152. Log of 3, throw it in the calculator. Because there's no other way to do this. 57 log divided by 3. Let's see if I do L. Oh, it is. Excellent. 3.68. 3.68. Da 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 da. 3. That's 3. And you can check any of these if you don't trust yourself or you don't trust me. Just x equals. Ooh, should this one be less than, well, if it equaled 1, it would be, that would be not good. X equals log of 15 divided by, no, don't make the mistake I just did. This is going to be a number less than 1, just so I don't have to, where'd my calculator go? 40, 43 log divided by 8 log equals 1.809. 3 log divided by 15 log equals 406. Well, that's kind of all I... Oh, no, wait. One more question. I was like, wow, that was really quick. Oh, hi, Julia and Emma showed up after I started. It's all recorded. pH scale is a measure of acidity. pH is the negative log of the H plus concentration. In theory, neutral water has a pH of 7. Acids are lower, bases are higher, blah, blah, blah. Tap water has a pH of 7 and change. To make a solution that has a pH of exactly 7 is actually somewhat difficult. So if cola has a pH of 10, or bleh, come on, brain, 2.5. How much more acidic how much more acidic is it than water, which has a pH of 7? So because we have a log, so the kind of easy way to look at this, the difference in pH is 7 minus 2.5. So it doesn't look like it's a big number. 7 minus 2 is 5, so it's 4.5. So the pH difference, which is that, well, I don't want this bit. We're going to, that negative is somewhat irrelevant. I want my eraser. The negative is just to change a sign. Whoops. Obviously the negative is to change a sign. These square brackets, for those who are in my chemistry, will see those tomorrow. Those cancel, so the H plus concentration difference in terms of magnitude is 10 to the 4.5. 10 to the power of 31623. So cola is actually, it's not just kind of a little bit more acidic. It's 31,623. Than a neutral solution. That's kind of a drastic difference. It's a logarithmic scale because there's 31,000 times more H plus ions. That's just a kind of application of this sort of stuff. If you're able to figure out and follow this, you're good. You can try some of those. That one you could actually evaluate some of these if you have a base in a single logarithm now, and I'll do that. But that's really all I have today because I don't want to start solving these kind of partway through and try to rush it, because what we have left is to solve exponential and logarithmic equations, which is, there's a couple strategies for exponential equations, there's a couple strategies for logarithmic equations, and then we can use properties of logs. Fundamentally, like this idea, this is solving that equation. That's where we need to go. How long, if the population multiplies by 7 every day, how many days does it take to get to 22? Well, 1.59. So that's what I'm going to stop today. Tomorrow we'll look at solving equations, which is somewhat important. And that's kind of, I'm sure if I went through, there would be a couple other topics that we just kind of glanced over, um, which I'll look for. Oh, I don't want to export that as a PowerPoint. That would be very bad. PDFs are better. Does anyone have any questions? If not, that's kind of, okay, you're going to make me do this, you piece of junk.
Okay.
Yes.
Are you gonna put like the notes that we just did on files?
I thought I did this morning. I'm sorry
I
if the,
didn't check. I just didn't know.
oh.
Maybe I saw something different.
I think they're there.
Okay, that's fine. I'll check into it. Thank you.
Sorry. They should be there. Oh, Brady Fudge. There's a, well, picture I haven't seen in a dog's age. Brady just,
I kind of gave up. Not in school, but like
well, you,
working.
oh yeah, it's all good. I don't take it personally. It's a lot of people trying to work and keep up on school and all of that. Uh, it, it, yeah, Julia, the original part's there, and then I'll finish it and put the rest up. I there's all sorts of people that just you don't have time, and well, if you're concerned about other classes, and it's all good. I'm it does I'm not offended in any way, shape, or form. All right, so I've got to finish those this morning and then do my taxes because those are due soon, and we've been lazy. But that's all I have for you guys today. We'll pick up solving stuff tomorrow. Hopefully, I can post some files beforehand. But other than that's what we're doing today. Hopefully, everybody's doing well and relaxing a little bit and enjoying the heat. Have a good day.
You too.
Thank you.
Thanks. You're welcome.
Thank you.
You're welcome.